Hi, this is Charles Maggio. Welcome back to our for epidemiologists. In this screencast, I want to continue our discussion of data frames and introduce the idea of how to index data frames. So let's get right down to it. There are three ways, really, that you can index a data frame. And a data frame is quite useful and quite flexible in that regard. So you can index a data frame by its position, by its name, which we actually haven't spoken about, and by logical vectors, which we have spoken about. Let's bring in the infertility data set, which we used when we first introduced data frames. And let's take a look at the first 6 observations in this data frame using the head function. Let's do that here. And so we see the first 6 observations and all the variables associated with it. Let's say for whatever reason we were interested in the first 2 variables, education and age. And we were particularly interested in the first 4 observations. There was something wrong with them. We wanted to take a look at it. We wanted to zero in on it. Well, as I mentioned, a data frame can be thought of as a list that behaves like a matrix. And in the same way that we can index a matrix by row and column, we can index a data frame by row and column using position numbers and the indexing notation we've been discussing. So if I wanted the first 4 rows and the first 2 columns, this is how I would index it. Infert, followed by brackets, then the sequence operator from 1 to 4, and the sequence operator 1 to 2. I submit that, and here I get this little snip of this data frame right here. And as I also mentioned, if you know how to index something, if you can figure out how to index it as a first step, then you could certainly manipulate it in any way you want, and you could replace any elements within it that you want. So for example, let's say we know that observation 26 here and observation 39 here were erroneous in some way, and we needed to replace it with NAs. Well, in a spreadsheet, you would open up the spreadsheet and somehow work with it and do it that way. And I'm just using this as an example for how to index. I mean, you might want to replace it in any way you want. But what I need to do then is somehow be able to index this and this. And the first thing I would do is I would say, okay, well, it's just these 2 right here. So let me just bring back this particular variable here, which is variable number 2, I happen to know. And if I bring that back, I have a vector of these observations right here. And I want to replace 2 of them. And what I can do then is, in the same way that I indexed it, I take that index that I created, and I was able to bring this with, and I replace it. I put it on the left side of the assignment operator, and on the right side of the assignment operator, I put the values of the vector or what I want to place there in its stead. And if I submit that, and then bring back that same series of observations, rows 1 to 4 and columns 1 to 2, I will see that I replaced them this way. And that's positioning. That's using the position. Now, with a very large data frame, as you can imagine, you might not be able to really figure out where or what number a particular variable is. So it might be more convenient to work with the names of the variables. And I didn't mention that lists can be named as well when I introduced lists, but lists can be named, and data frames, when we think of the names of data frames, really what we're referring to is the names of the variables. And there's a function called names, and if I submit the infertility data frame as an object, as an argument to that function of names, I get back all the names right here. And you could work with names. Now, I'm going to mention this right here. Let me just take this right here. I'm going to cut it. I'm going to put it over here first because I think this is kind of a better way to introduce it. I can just index the variable itself simply using the name of the variable without anything else, without any commas or any other reference to dimensions, in the indexing bracket behind the name of the data frame. This is referred to by various names. I've seen it referred to as the slice index. It's part of the programming behavior of many statistical programs. I actually find it a very useful way to just index that particular variable. So if I were to write infert and then the education variable, right? And I see here education is the first variable right here. And I just put that right there. Well, it returns the entire vector of that. It doesn't return it essentially, it doesn't return it as a vector. That's kind of interesting. It returns it essentially as a slice of that data frame. That's kind of interesting. I hadn't really realized it before, but it does that, and it works very nicely like that. So if I were instead to try to bring back that particular variable. And using numeric indexing, what I would do then is I would leave the row dimension empty and specify the first column, that variable, and let's see what we get back here. And I get back the same information except as a vector. So the big difference between using this slice index and using numeric indexing, and what I'm going to be doing over here, is the kinds of results it returns. So if you use numeric indexing, you'll get that vector. If you use this slice index, you'll get essentially a slice of that data frame. And you could specify a couple of different, let's bring back the names for a minute. I've been working with these contiguous ones, but let's say I wanted age, education, and parity, and they are not really next to each other. Education and age are, but it's education that skips and then it goes to parity. Well, this is a nice way to just pluck out those two that are not near each other, return that, and we get education and parity. We get those two slices right next to each other. So that's using the slice index, which is sort of like a subset of the naming index. You can use the names of variables within the kinds of row and column dimensional indexing that we've been doing up until now, and that will return something else. So let's just subset it to the first 4 observations and use education and age over here. And what do we get back? Well, we do get actually a little slice as well. Anytime we name it, we get this little slice. So that's kind of interesting for me anyway. Again, if you know how to index something, then you can replace it. And we're going to do the same thing that we did last time. Here we have this. Let's just bring in the infertility data set again. Let's set it back to where it was. Oh, you know what? Even better. Let's say we get these results. We know these NAs now are actually age 22 and age 23. And we want to replace those NAs. Well, here's how we would do it using names instead of just simple numeric indexing. Submit that, and now bring that right back. And we see that we replaced it with age 22 and 23. Finally, we can index using a logical vector, and this is a very useful and powerful approach to it. And let's start off by just making a little table of the parity variable. The table command can create a matrix, and we've seen that. Basically, it'll do cross tabulations for us. When we've provided a single categorical variable, it just counts up that variable for us and gives us a count. So basically there were 99 women that were power 1, power 2, power 3, power 4, and then 6 were power 5, and then 8 were power 6. Well, let's say we happen to know that 5 and 6, these categories for parity, were erroneous in some way. They were incorrect. There were no women that actually had 5 or 6 children. And we want to assign NA to it. Well, like I said, the first thing we need to know is a way to index it. And one way we can index that is basically look for every observation of parity where the outcome or the result is either 5 or 6. And we could write a conditional statement by saying infertility parity equal 5, or infertility, or using the infix operator or the pipeline operator, infert parity equivalent to 6. Now remember, this double equal sign means equivalent to. So if we were to submit that, what we would get is each observation of parity that meets this conditional criteria. In fact, if we wanted to, just break it down even more, just to make it a little bit clearer what's going on here, because you're going to see something, I don't want you to think it's magic, but let me copy this, right? If I just submit this statement, this is basically asking the data frame a question. It's saying, at what point or where along this vector of the parity variable in the infertility data set is it equivalent to 5? And it's essentially querying the vector. And if I submit that, what I get is a series of trues and falses. And whenever it's equal or equivalent to 5, I get a true, otherwise I get a false. Same thing with equivalent or equal to 6. Whenever it's a true or equivalent to 6, I get a true, and otherwise I get a lot of falses where it's not. And when I put them together like this, where I say equal to one or the other, let's copy that and put that right here with nothing else, I submit that, and I get another series. And anytime it meets one of these criteria, because the infix operator means or, it will return a true, otherwise it will return a false. Well, I'm using that vector, this object, this conditional statement that creates a logical vector to index that particular vector itself. And if I do that, what it's going to do is it's going to test this vector against this series of trues and falses, and every time it meets it, it's going to return a true, and every time it doesn't meet it, it's going to return a false. If I submit that, here's what I get. I get basically every place that on the index, it indexes, it creates its own index. Every place on that vector that it's true, it returns that particular value right here. And if I can index it, if I have all these values here, now I know how to index them, I can replace them with NAs. So I am going to replace them with NAs, which I do right here. Now if I do my table command, what I find is I no longer have these values for parity. I am restricted just to the valid values, and the NAs are dropped. That is a quick introduction to indexing data frames.